All right, today we're going to take a look at Congruent Triangles, lesson number 4. And what we are dealing with is actually something I have brought up a whole lot over the last while. It is Isosceles Triangles. And I bring them up a lot because they come up a lot. And there are a couple of special rules that apply to Isosceles Triangles that we need to practice and get through. So it should actually be a pretty quick lesson because a lot of these things we've already talked about. All right, we need to label this thing with the following: vertex angle, base angle, legs, and base. So let's do that first. So the vertex angle is the angle at the top. Okay. So the vertex is where the two matching legs come together, and so that would be considered the vertex angle. So we'll label that here. All right. Now, then from there, you've got your base angles. Now, the hint with the base angles is that there are two of them, so we're going to mark the two at the bottom as base angles. All right, there you go. Now, from here, we're supposed to label the legs and the base. The legs, it's pretty obvious. Those are the two matching parts. Whenever we're talking about an isosceles triangle, the legs are the matching parts. And then obviously, if we're going to have base angles, we probably need to have a base, which would be the bottom side. All right. Now, if we were to hypothetically label this triangle and we were just to call it triangle ABC, and we'll just go clockwise on this, we'll say A, B, and C, then we could make a couple of statements regarding things that match. For one thing, we could say the legs match. So we could say that segment AB is congruent to segment AC. The legs on an isosceles triangle match. Now, the other part, and I have brought this up a bunch, but we haven't given it an official name, which is important because when we use it in a proof, we need to actually consider this. It turns out in an isosceles triangle, if you have two congruent sides like this, you will also have two congruent angles. So the other statement that works is that angle B is congruent to angle C. So these theorems that we are about to write are related to that fact. And so just so that we don't get too fancy about it, the first theorem is just named the plain old Isosceles Triangle Theorem. Now, sometimes, some books, some places online, you will also see it as the base angles theorem. Either way, I mean, it doesn't really matter. It's something that we've already talked about so many times that I don't really need to introduce it. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. Now, to go back and explain what that means, the phrase opposite means farthest away. So if I'm talking about a congruent side, the opposite angle is the diagonal one farthest away. And that goes here, and that goes here. That's the visual that I want you to get when we start talking about this theorem. You need to go opposites. Okay? Now, this is not going to be a surprise to anybody because we have done this so much, but there is also such thing as the converse theorem. And then, of course, we are going to name the other one, the base angles converse theorem. And I think you know what's coming here. The first rule said if two sides are congruent, then the angles opposite the sides are congruent. So here, the converse would be if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So more or less, the most important thing you're trying to get out of this is that the idea works both ways. So now you could take the angles and go opposites to match up the sides. Okay, so the concept of a converse is something we did in the previous chapter, and people did pretty well with it. So now we're going to apply that idea to isosceles triangles. All right, so let's do a few examples relating to this, and then we'll wrap it up. If the measure of angle x is 71 degrees, what is xwz? Now, please use pencil to do this marking here, because for question number 3, we're going to use different measurements. We're just trying to set up the idea of how some of these questions would look. So if the measure of angle x is 71 degrees, what is xwz? Well, because the sides are marked as congruent, that means the opposite angles will also be congruent, which means we're going to have 71 degrees right here. So if you want to know what xwz is, that would just be the third angle of the triangle. So if we already know that we have 71 and 71, that means we've already used 142 degrees. And if we've already used 142 degrees, then we could just subtract and we could say 180 minus 142 to get our leftovers. And that means the measure of angle xwz is 38 degrees. Easy stuff so far. Just subtraction. Problem number 2. If WY bisects angle XWZ, what is the measure of XWY? So now we bring in a word that we actually used in one of our proofs lately. We talk about bisecting. And what we need to know about bisecting is that whenever you bisect an angle, it's chopped in half. It's exactly the same idea as what a midpoint does to a segment. If you take the midpoint of a segment and then you break it up into 2 parts, those 2 parts will be the same. So bisecting an angle cuts it in half, meaning instead of 38, if we just want to know XWY, that would just be this little part right here, which would be 19. All right, now, for the third example, it is a new example, so you can erase the 71. This no longer applies. So we're going to erase the 71 here. We're going to erase the 71 here. If angle x is twice as large as xwz, what is the measure of angle z? So I don't know any of the angles. I just know that this thing right here is going to be twice as big as this right here. So if I just call that x degrees because I don't know what it is, I could call this 2x degrees. And then since the triangle is isosceles, I could also call that 2x degrees. So to do the setup here, it wouldn't be too bad at all. I could just say x plus 2x plus 2x equals 180. So that'd be 5x equals 180 if we combine like terms. Then we divide by 5, and you find out that x is 36. Now, did that answer the question? No, because it told us we needed to know the measure of angle z. So the measure of angle z equals, well, z was 2x. 2 times 36 would be 72 degrees. Okay. All right. Last thing we're going to do, which I'm sure is going to bring joy to your heart, is we are going to do a proof. Okay, so there will not be any joy. It's okay. We'll get there. All right, so we're going to do statements. We're going to do reasons, and we're going to get this thing going. Now, you have a couple of statements that were given. So I think that would probably be a good place to start. Whenever you aren't sure what to do to start, make sure you put your given statements there because it's good to just get them over with. So y is the midpoint of xz, and wx is congruent to wz. So we have a matching side already. Now it said to prove that these triangles are congruent using side, angle, side, which stinks because that means we can't use the reflexive property. You know, usually in a proof like this, we use the reflexive property down the middle. We're not allowed to do that this time. So we have to pick side, angle, side. Now, I'm going to look at this second hint right here. Wx is congruent to Wz here. That's going to be my first side. I'm going to use that. That's going to match. Okay. Now, if you look over here, y is the midpoint of xz. That means y is in between x and z, halfway, which means these two pieces that are left over also have to match. So I'm going to say next that xy is congruent to zy. Now, why was I allowed to do that? The reason you're allowed to make these two equal had to do with that statement we did earlier regarding midpoint. Whenever you have a midpoint, it breaks things up into two equal pieces. So if we're trying to come up with a good explanation of that, I'm just going to say definition of midpoint. And that covers me because now you look and you say, oh, that's the midpoint, which means we have two equal pieces. So again, I already talked about this. You're not allowed to use the reflexive property here because it said to use side, angle, side. So we have to come up with a different idea. And the different idea would be if we're going to use this side, and we want to make side, angle, side work, we have to use the angle in between, which would be this and this. So I'm going to have to do something with angle x being congruent to angle z, which is where today's lesson comes in. The reason I know that angle x is congruent to angle z is because of the theorem we just learned. Remember, we had sort of talked about how we know, we just needed a good reason. We needed to have an explanation as to why I'm allowed to mark those two angles as congruent. The Isosceles Triangle Theorem is the reason why. And then that leaves us with the thing we're trying to prove, which we put at the bottom, and the reason that we're trying to prove it. They actually already gave us that as well, so I can just copy and paste that. All right, so that is what a side, angle, side proof would look like. You could have also done it with side, side, side because of the reflexive property with that line in the middle, but because it told us we had to do it this way, we had to do it that way. All right, thanks for joining me. I'll see you next time.